All right, so as I was saying, my name is Derek Schultz. I taught here for a 7-week class last year. So we were trying to mad rush everything into a 7-week class. It was really hard. So now we've got a 14-week class, which will be great because we can take things a little bit slower and hopefully get everybody up to speed. So a couple notes about this class. This class won't be heavy on coding. So if you're really excited to learn PyTorch or TensorFlow, you won't in this class. I guess I can probably give you some material if you're interested in that. But for the most part, like we're just going to use a bunch of pre-made models because it's way easier than having to learn how to write your own models and stuff. So should be pretty chill. Let me just go through my slides here and get started then. So here's what we're going to try to get through today. I don't know if we're going to get through all of it. If we don't, that's fine. So we're just going to talk a little bit about how we want to set up the class. We'll do some intros just so I can get to know everybody. I'm very bad with names, so I apologize if it takes me a minute. But I promise I will figure it out by the end of the class. We're going to do a couple little fun demos just to get started and just to get sort of like warmed up. I'm going to talk a little bit about just like the basics of machine learning. I don't know what everyone's level of use with machine learning in the past has been, whether you use Runway or other things. So we'll just cover a little bit of basic stuff. I want to go through some cool ML art projects just so you're aware of them. And maybe you can start to research those artists and learn a little bit more about their work and maybe get inspired by it. This class will mostly be using Colab. I previously had taught with Runway, but apparently a lot of you guys learn Runway in other classes, but you don't learn Colab. And Colab is actually probably going to be like, I would say for most of machine learning art going forward, Colab will probably be the tool that we'll use. We'll talk about why that is, what Colab is, how to use it, those sort of things. We will definitely take some breaks in this class because sitting here for 2.5 hours is pretty annoying. And then I'll just do a quick demo of Colab and we'll do one more demo before closing out for the day. I actually don't think there's going to be homework today, in part because I know lots of people are moving classes for the first week. So it's kind of ridiculous to ask people to do homework if they're not here for things, that sort of stuff. So we might cover a lot of this material again next week, more as a refresher. We'll try to layer on some additional stuff. But it should be, this week we'll just sort of get you warmed up and used to Colab. If you want, put this in the class, but if you want to actually like do homework or like just get used to things, I'll give you a list of Colab notebooks you can play with and sort of learn from. That'll probably be it. You've probably heard this from every other teacher so far this semester, but like, if you're not feeling well, please don't come to class. I really mean that. This would have been true 3 years ago too. Like, I don't want people coming with colds because I don't want to get a cold. I don't want anyone else getting a cold. Please just stay home. Like, I'm not going to be mad at you if you miss a class. We're going to record every session. I record all my sessions anyway, just because they're pretty dense. So you might want to go back and review them anyway. So I'll make sure that like, no matter what, like if you're not feeling well, just stay home. We can set up Zoom, like everything is fine. Like there's no, I'm honestly more used to teaching over Zoom than I am teaching in person at this point. So like, it's fine, like we'll figure it out. You know, so at the end of the day, like make sure that you put your health first and like the class health first as well. You know, that's just going to be key for now until God, who knows, whenever this pandemic is over. So, you know, just take care of yourself first. Like, this is a grad school class, like, you know, it's pass fail, like your life is not dependent on this class. So just, you know, do what you need to do to take care of yourself. Also, like, if you're just fucking exhausted because life is exhausting right now, like, feel free to take a week or two off. Like, again, it's really not the end of the world. You will survive. Like, this class is going to be here whether you are feeling well or not. Like, so just do what you need to do for yourself first. I should say that, like, for God, for some reason, like shit breaks out again and like over half the class is gone, like we're just gonna do shit over Zoom. Like there's no reason for me to like force everyone to come in with like a reduced class. So with that in mind, like please let me know ahead of time if you know you're not gonna make it. Like if you know you're sick on Tuesday, like please just email me or message me on the other platform. Just say like, hey, I'm not gonna be in class today. I don't care. Like, I mean, it's not the end of the world. Like, just give me heads up because if I show up and no one's here, like that's gonna suck for me. Yeah, so like stuff's gonna change week to week. I'll make sure I email everybody. God forbid I don't get sick. If I do, like the whole class go over Zoom. But you can show up here if you want to. I mean, I know last year when I taught, like people were kind of frustrated because you can't talk to each other. You can't like sort of like, learn from each other in a like over Zoom. It's kind of annoying. So I totally understand why we're doing a class in person. I'm really excited to like have everybody here. We can do some small group stuff like in person. But we're going to have to be pretty flexible this semester just in case stuff happens. Cool. So why don't we do this? Why don't we go around the room? If everyone can just tell me their preferred name, what pronouns they like to use, whether this is your first or second year at ITP, or if you're part of another program, and then just give me like, I don't know, one sentence about why you're interested in taking this class. So why don't we start over here?
So hi, my name is Luhan Rong, and I prefer she or her. And I'm the first year of ITP, and I'm taking this class because first my roommate recommended, and second I want to learn more about machine learning.
Cool.
I'm Phil, he, him, second year. I just think GANs are fun.
My name is Lauren Shears, and I'm a first year ITP, and I don't have any background in machine learning, so I was kind of like curious about it.
Hi everyone, him. I am a first year, and I am hoping to use my own art and feed it into these models, and generate work from it. So.
I'm Lily from she, her, on second year. First of all, I was a bit curious about it, and it might be related to my previous.
Hi, I'm Tony. He, him, first year ITP. I'm pretty interested in machine learning, and I'm excited to learn.
I'm Spencer, he, they. I'm first year. I'm taking this class out of curiosity, but also I think that I don't want to explore any place anything like this.
I am Lorena, first year, she, her, and I took some machine learning classes. I mean, Google Colab, I don't know who's called, but I loved it, and I look forward to learn more.
Was that here at ITP?
Yes.
Who was teaching it?
Jean, correct?
Okay, cool. Yeah.
Okay, Oscar, he, him. I'm a first year ITP, and I'm taking this class because I'm curious about machine learning.
I am Hongwei, he, him, first year RTP. Why taking the class? I think last semester took the hypercinema, and they kind of doing something was the wrong way. I kind of find it interesting. I want to learn more about it.
I'm Suraj, he, him. I'm a first year ITP. I'm taking this class because I think I could use this in my work. I want to explore.
I'm Zoe. I prefer she and her. I'm first year. I really enjoyed the AI part of hypercinema, and I feel like this could be a cool way to expand my art practice.
My name is Strong, also go by Chelsea, preferred pronoun, she, they, interchangeably. I'm a first year ITP. I came from like a drawing, computer science, and art background, so I had like some knowledge about machine learning. Just hope to learn more about it.
I'm Cheer, ITP first year. I take this course because I'm interested in machine learning and I want to produce some artworks.
It's a true first year, prefer he, him. So the reason why I take the class is because I'm curious about GANs and I want to learn about machine learning. Yeah.
Cool, awesome. Who taught the hypercinema class?
Okay.
David. Okay. All right, cool. Awesome. So I'm just going to give you a quick little background on me. So I'm actually, by day, I'm a product designer. So I will be running out of here at whatever, 11:30 or whatever to go to work, which sucks, but so it is. But in the side and for the past maybe 3 or 4 years now, I've been teaching classes around machine learning. I actually mostly teach outside of the university system. I just teach classes to other artists and designers and professional working folks. So This is actually the second time I've really taught here at NYU. So, and a lot of what I'm really interested in teaching, and hopefully you'll learn out of this class, and we'll get to objectives in a minute, is like, part of the process of doing machine learning art is sort of like changing the way you think about interacting with computers. If you're used to doing stuff in processing or open frameworks, other things, you're used to sort of like explaining exactly to the machine what you want to do, or maybe using randomization and those sort of things to slightly change and introduce some randomization process. Machine learning is almost the opposite. You're sort of like, I don't like the metaphor of like playing with another human / machine, but like, it is sort of true that you sort of have to learn how the machine learning model works and then sort of like work alongside of it to actually manipulate it in the direction you want it to. So we're going to cover a lot of that in class, about data sets, those sort of things. So, but I think it just requires a slightly different frame of mind when you work with machine learning models. So hopefully that's like a big thing you got as class, is like, some of you may end up hating it too. Like it is like not the easiest thing to get used to. It is very different than probably a lot of the other generative art processes you're used to. So I learned from many of the same people you did. I took a class at SFPC 5 years ago now, with a lot of these folks. Most of these folks now teach ITP. For any that don't, you should definitely look up their names because they're very interesting people. I met Chris when he was an ITP grad student here, before he started Runway. So I'm sort of familiar with a lot of the Runway folks. Yeah, I mean, this is, probably today I would still say this is like, maybe at least half the list of people that do ML art that I would recommend looking into. I might show some of their work. I think I show, I don't know who's this work I show, but in the inspiration section, I'll show you some other artists to check out as well. So my first machine learning projects were this. It's sort of funny to look back on now because they were very low res, also just not particularly very good. One of the, again, like I mentioned, one of the challenges to machine learning is that it just is sort of a slightly different process for your brain. So I took this like intensive SFPC class. It was like 1 week for like 5 hours after work every day. Did some of this stuff, and then I was like, I don't ever want to touch this again. So I put it away for 3 months, and I sort of like slowly came back to it. And I think what, at least especially at the time that this was coming out, like basically the only person who had material that you could learn on your own was Gene. He had some of his ML4A classes up. And since then, it's, so go ahead, yeah.
Can we have the front lights?
Oh yeah, how do we do that? Would someone mind doing that for me? Perfect, thank you. That better? Yeah, go for it.
I have a question too. So what did you use to make this? Did you use Python or did you use?
Yeah, so this is, so we'll talk about what these models are. This one here on the left is a GAN. This is like really early, Christ, I don't even know what this would have been called at that time. It was just like a basic vanilla GAN. This is a style transfer model. We'll talk a little bit more about style transfer over the next couple weeks and what the two different processes do. But these were done in probably IPython notebooks. This is before Colab existed. So this would have been, yeah, this would have been done on like a paper space server running like an IPython notebook. Thankfully, we don't need to worry about that. Basically, IPython notebooks are now the same thing that Colab is. I'll talk about that in a little bit, but this would, I mean, this is very similar to what we'll do. Well, the work will be better, but this is very similar to what we'll be doing in class for the next couple weeks for sure. So I did this work. It was very bad. I felt kind of frustrated because you have to set a lot of stuff up on servers, and learning server stuff in Linux is no fun. Thankfully, you don't need to do that in this class, so you'll be saved from that. I started doing more work, started doing illustration work. This was done for the Baffler, which is sort of a leftist magazine. I was doing illustration commissions for them. This is again style transfer. So, you can sort of see the difference between this on the right and this on the right. And on the left is a model called Munit, which we might look at in class. It's kind of a little old and out of date nowadays, but I'll cover what this is. This is essentially an image translation model where you can take one image and translate it using another image. So started getting more comfortable with the material. I was doing commissions. I've done a bunch of commissions for the New York Times. I just did one for the New Yorker. So all of my work is more or less image and video. So I don't do a lot of work with sound. If you're interested in sound, I can help you a little bit, sort of point you in the right direction. But it's not really a strength of mine. So we'll mostly be doing image and video work in this class. I have done a lot of video stuff recently. This is, let's see if we'll skip ahead a little bit. Well, you can sort of see. So a lot of my work now uses film and sort of filmic techniques, so abstract cinema stuff. This might not be the best example, but if you look, you can sort of see this matches two images together using their body positions. This is probably the best part to look at. So this actually uses two machine learning models. The overlaid sort of like graphic part is a model called next frame prediction. We'll definitely look at that in class. And then the matching system is, sorry, this is flashy if that's a problem for you. We're using OpenPose, which I think you might have, like someone like Yiming would probably be teaching stuff like that.
How, so is it like pulling from like thousands and thousands?
Yeah, it's pulling from millions of
and it
images.
does it that quickly in that?
It doesn't do it that quickly.
Okay.
This is
it's
not
not
real
real
time.
time.
This is sort of like just you basically set up all the process, it processes everything, and then I put it back together in like After
Gotcha.
Effects or video
Okay,
program. Yeah,
okay.
yeah. There are some things that are fairly real time. Like the thing is also with machine learning, pretty much every year we like sort of jump and things get faster and easier and quicker.
Right.
This is definitely not one of those processes.
Sure.
Yeah. So one thing we'll also look a lot at, this is actually a great example. This thing we're going to look at today in class. This uses a text to image model. So what you can do is this is feeding in poetry and it's sharing images based on those poetry. We're actually sharing video from this. So text to image is one of the more popular machine learning models these days for creating image work. We're actually going to look at a model that was the state of the art as of like a year ago for our first demo, and we'll see how bad it is, and then we'll see how good, like, remember how good this stuff is. So we'll talk about like sort of why that is and other things. But yeah, so I do a little bit of stuff with this. Nice thing is it's fairly easy to generate video with this. Again, this isn't real time. This is probably, will probably take, this took maybe 4 or 5 hours to render, but that's still way slower, way faster than it used to be. Out of here. Okay. So I will send around slides after class for anyone that's interested. This is just some place to find me. So portfolio site. I mostly use Instagram for sketches and other things. I'll be talking a little bit more about my YouTube channel. Like I said, I teach a lot of classes and they're all on different material. All of those classes and the recordings are up on YouTube. So if you really want to go deep into this stuff, you can. We definitely won't cover everything I cover in my classes. We'll cover a lot of stuff from those classes. So you can email me. The honest answer is I'm bad at email. So in general, DMing me, like we can set up, I think what I would recommend we do is I have a Slack channel. We can set up stuff there to talk. If there's other materials, I don't know what you guys use in other classes to just sort of talk back and forth or like share work or whatever. I'm fine with doing whatever works for y'all because, you know, you don't need to sign up for yet another Slack or another Discord. But basically, like, whatever we end up using, if there's a DM function, like it's probably better to DM me than it is to email me. Email is fine. It's just like not something that I am good at responding to. So especially if you have questions, it's probably better to just DM me or whatever the systems are. So this is sort of my rough schedule for the class. As I mentioned, I previously taught a 7-week class here. So that was sort of like 1 through 7 was just sort of what we did. I think what we'll probably do is we'll sort of keep on that schedule. Just so the first half of the class will be more just like, I'm going to teach you a bunch of different stuff, a bunch of models to use, sort of like ways of thinking about machine learning. And then the second half of class will be sort of for you to really explore what you're interested in. Some of you will get really interested in one thing. Some of you might be like, I don't really know what I want to do, so let me explore some more. Some of you might have interest in a particular model that we didn't cover in class, and I can help sort of work you through that. So I think that'll be a nice way to sort of like give you like a good foundation of machine learning and then also let you sort of explore a little bit. One thing I also highly recommend for a lot of stuff, like if you spend 5 weeks on a model, you will likely have spent the most time outside of the researcher who made the model. So, which is scary, but very true. So I highly recommend that you document your work. So if you have a blog or just, you know, if you like getting in the habit of writing up like how you learned something or what you learned about it is really important. So especially when we get into the individual projects, I highly recommend that you do a lot of documentation. Because in a lot of cases, like quite literally, like for me, like when I started getting into a model called StyleGAN, which we'll look a lot at, just me like recording videos on how I did stuff was like, got me a lot of like people followed me, found my work, that sort of thing. And likewise with you, like just sitting down and being like, okay, here's what I did, here's the 10 examples of things I ran through it, and here's what I found. Like that's gonna, like people are gonna immediately start asking questions, and you will all of a sudden be known as an expert of things, which can be scary. But yeah, I think like, you know, it's probably a little different now, but even a year or two ago, I would have said that like teaching a class like this would have meant that like you were probably one of the only people in the world to like work on stuff like this. A little different now, which is probably good in the long run because it's easier to find answers to things you get stuck at. But it's still really early in a lot of this world, and I think you'll find that just sitting down and documenting your work is really powerful, and will get people to notice you if you're interested in jobs or being an artist outside after ITP. So I have set up a class page for us. It's just a GitHub page. So I'll be adding all of the slides every week there. So if you want to write down this URL here, it's just dvschultz.github.io/ITP2022-GANs. I'll send this out after class as well. So, you know, don't worry too much about it missing it. But this will include all of the links for every week. So every week we'll do, you know, I'll do the slides, I'll post up the recording there as well. And then any links to notebooks or other things that we learned or we looked at in class. Yeah, I'll send it over to everyone's email. Yep. So there'll be a class page that'll also list the homework for the week. See, I might talk about homework more, but like homework is more for you than it is for me. You know, if you're interested in learning about machine learning, the only way to learn it is to actually do all of the projects and like actually get in it and like learn about errors and other things. So homework is really there for you. I'll ask that you send it in to me either over email or whatever, you know, Slack or Discord or wherever we end up using, just so I see what you worked on. So maybe I can help you, or if I see common errors across the class, I can the next week sort of help people out. But you know, this is a pass or fail class. I'm not going to grade your work, but it's more for you. I'll make sure that when we do lectures that all the slides are available probably the day of. So they'll probably be posted on the class page. If you go to the class page today, you'll see the slides for this week are already there. As I mentioned, I'll be recording all this. It'll all be over whatever our Zoom session is. So hopefully my voice gets picked up fairly well. I can't say the same for everybody else, but I'll do what I can. So yeah, what is everybody using to discuss with other classmates about classes? Are you guys using a Slack, a Discord, anything?
Mostly Discord.
Mostly Discord, okay. So let's use Discord. So what I'll do is I'll set up a Discord for us. I'll send it out with email and people can just sort of sign up. Again, I would say for this stuff, like you've got what, 3 other classes going on for a lot of you. So like, you know, you're welcome to post questions or like chat there. But for the most part, like I'll be there to answer questions. You know, I'll try to answer like pretty frequently throughout the day if you'll have questions. But I don't want to make like active participation in Discord somehow a part of your grade or whatever. So I'll have it up for people who are interested. I do have like a semi-public Slack channel for all of my other classes. I'll send that link out if anyone wants to join, because there's lots of questions and other people who are there. So if you just want to check that out, you're more welcome to. But I won't make anyone, you know, there's no requirement to sign up for those things. So yeah, I would say like if we set up a Discord, it's probably best if you just DM me there. So it'll be a little bit easier for us to chat and that sort of thing. So as I mentioned, I do have a YouTube channel. You can go here. So my YouTube channel at the top of the page here, you'll see there's a list of my recorded classes and the recommended order I take them in. So there are 1, 2, 3, 4, 5, 6, 7, 8 classes at this point. all on different topics. And if you were to go from this one all the way to the end, it's probably 80 hours of material. So I would not recommend doing it that way. I might link you to videos that I've recorded, tutorials I've recorded from my YouTube channel, not because I want to blow you off, but because there's just a recording there and it's just easier if you like watch that and then ask me questions. So probably not until we get to the individual projects where it might be like, oh, I've actually like already used this model. Here's a tutorial on how to use it, that sort of thing. So obviously like for this class, like the instruction that I will give you in lectures, I'll give you, I won't force anyone to watch any of these recordings because they're pretty loose. They're like this. So, but just be aware that like there is a bunch of material here. You probably won't want to start deep diving into it until a little bit later. But if you're interested, it is here. And as I mentioned, there's a public Slack. Lots of people are on there. Lots of people like yourselves, people just getting into machine learning who have questions. You are more than welcome to engage with people there or not. Doesn't really matter. So I'll send out a link to that as well as once I get our Discord set up. Okay, so objectives for the class today or for like the 14 weeks. The real key that I want you to get out of this class is that every model that we use does something slightly different. And matching what you need it to do to the right model is the really important thing. A lot of people will be like, hey, I want to do this with StyleGAN. And I'll be like, no, that's not a StyleGAN model. That's a next frame prediction model, or that's a unit model. So we'll talk a lot about the different types of models, how each model sort of works more in like a, not like a code way, but just in sort of a mental model kind of way, and when to use one or the other. So a lot of this, the next couple weeks, will just be like, okay, here's a GAN model. Here's how it works. Here is a image translation model. Here's how it works. Here's how a text to image model works. Those sort of things. So we'll start with that, just to get comfortable with sort of the nomenclature, the language, what types of models are what. We'll also start to use pre-trained models. We'll talk a little bit about what a pre-trained model means to generate image and video. So basically, like we'll start by using other people's models, other people's data sets. Once we get a little more comfortable with that, then we'll move on to making our own data sets. Making our own data sets is the biggest pain in the ass. Like it is the most time-consuming part of this job. It is essentially writing the code for your model, and how you build your data set really matters. So we're going to talk a lot about like what type of data set does this model take? How do we format our data set the right way? Those sort of things. And we will train our own models. So probably the first couple weeks of class, we'll do sort of like group models where we'll all help build a data set together. Then we'll train it each separately, sort of see what happens, because each of our models will look slightly different just because of randomness in these models. And we'll sort of learn through that. Once we get to the individual projects, you'll probably want to train your own data set, your own model, and you'll have to spend a week or two building your own data set. It does take some time. But I'll talk through all that. I've got a bunch of tools set up to help us make data sets a little bit easier, those sort of things. And then lastly, we'll talk about like once you've got a model, what are the other things you can do with it? From purely ecological standpoint, using high-powered GPUs is a lot like crypto mining. It is very energy intensive. We don't want to be wasteful. So, in this class, like if we waste the model, like whatever, but long-term, we want to like, once you get a handle on how to use your model, you want to maximize the value of that model because it's going to take you a couple weeks to even train one of these. So you want to make sure that you get the most value out of it. So we're going to talk about like, how do I hook a GAN model up to, other data sources, or how do I think about animating things using outside data, or can I bring it into a third-party application and begin to build and use that? So we'll talk a lot about that. This will probably be more of like, once we get to individual projects and you have an idea for something, I'll help you sort of like, okay, we've got a model here. How do we bring it into this? Or how do we utilize this in either a real-time application or in an exhibit or other things? So this will kind of be ad hoc as we determine what projects everyone wants to work on. So there will be a fair amount of homework every week. Just going to warn everybody now. Part of that is just because this is a very new process for everybody. So the best way to learn it is just get invested in it and spend time. On the lighter side, which I would expect, I would expect 4 to 6 hours a week, just to sort of like sit down, rewatch videos, like work on like previous things that you've tried. Playing with models honestly takes a little bit of time to just get set up. We'll go through that today. At the higher end, when we do the 10 hours of work, that's like building your own data set because you're just gonna have to go and like scrape a bunch of data, clean things up, that sort of thing. So I'll highlight, when we're approaching that time, just so you can prep yourself a little bit. But, and again, it's sort of like what you put into this class is what you're going to get out of it. So a lot of the homework is just like, try stuff, break things, and then come to class and be like, what the hell did I do? Or like, how do I fix this? Or what does this error mean? Or what does this mean? So a lot of it is just like, if you try stuff and just to jot down questions, like then we can come into class and talk about them and we can learn more that way. So a lot of it's just like, try stuff, break stuff, and then we'll figure it out together. That's why I make the homework. That's why I make it exist. So it's like more for you to learn through experimentation. Okay, so we're gonna call this Discord. So the only required software for this class will be Discord and Colab. Colab is free on some, it's free, but it's slow. So basically like you pay for the GPU that you're given. On the free side, you're gonna get a really cheap, crappy GPU, which means all your stuff is gonna take longer. There is a $10 a month plan. We'll cover this a little bit more. There's a $10 a month plan that'll get you a slightly nicer GPU, which will be slightly faster. And that's sort of what I'll assume everyone has, just because it'll like everything I've built around our models and that sort of thing will be with the assumption you've got that, because there are some like threshold requirements. There's also a $50 a month plan, which I don't expect anyone to get, but that'll get you the fastest GPUs. So maybe what you want to do is, what I recommend doing is, don't pay for Colab yet. Wait until I tell you to pay for Colab. Pay for Colab at that point at the $10 a month plan. And then when you get into maybe your individual project, you might decide you want to upgrade just to get a faster GPU so you can train models faster. I'll leave that up to you. I want to save everyone as much money as possible because I know how expensive college is. Like, shit's expensive. So like, I'm going to try to save you as much money as possible. But I will recommend that you at least get the $10 a month plan at a certain point, because it's just going to save you a bunch of headaches. So that would be my recommendation.
And there's no way to like use your own GPU if you have a powerful enough.
If you, it kind of depends on what GPU you have and what you're running on. You pretty much have to be running on Linux, and you have to have a 16 gigabyte GPU or higher, which is now like even some of the gaming GPUs have gotten to that point, but still a lot of them only hit like 12 GPU, 12 gigabytes.
Doing that, if you have both of those, but that would just be a separate entity relative to Google Colab, right? Like
Yeah.
That's just like your own training.
Yeah, pretty much. You can kind of set up Colab to run off that, but it's still like, it's honestly easier to set up your own environment.
Gotcha.
If anyone really wants to do that or has that, like I'm happy to help you get set up on it. That's how I run my own stuff at home, but it's very expensive and it's a huge pain in the ass. Like honestly, Colab is so much nicer because you don't have to deal with installation, upkeep, like setting up like all the right environments and that sort of thing. So I definitely recommend not doing it unless you like already have it and you cannot spend $10 a month. Cool. Okay, so before we take a break, let's do a real quick demo here. So what I'm going to ask you to do is think of a sentence for me. So basically just think of any sentence, maybe write it down, and then what I would like you to do is once I'm set up here, I'll just take in the sentences and we'll do a quick little text image demo. So just think of a sentence, maybe jot it down really quick while I get set up here. For now, don't worry about what I'm doing. Like this is Colab, and I'll walk you through all of this later today. But for now, I'm just going to get us set up here. And of course, today is the day that I get a good GPU, which means you have to downgrade for this particular model. All right, so while I run this, so who's got sentences for me? Someone just shout one out. Coffee is hot. Okay. Anybody else?
I can't sleep.
Okay. Who else has one?
It's cold today.
Go on, come on.
In the dark times.
Sorry, one at a time. What was that?
in the dark times, will there be singing?
Okay. Did I get that right?
I'm hungry.
What was that?
I'm hungry.
You're hungry? Okay.
Standing in a field of bones, my eyes wander towards the blood red sky.
Did I get that right?
Yeah.
All right, cool. All right, what else?
The tree was covered in owls.
Grass is red, the moon is orange.
Anybody else? Okay, cool. Well, we're still getting set up here, oh, and I can't spell coffee apparently. So we'll cover collab in just a minute. But what I want to do is just a quick little demo here. All right, why don't we do this? Let's take a break. So let's take a 10-minute break. That'll give me time to run all this stuff. And when we come back, we'll look at some of the results. Sound good? So come back at, well, let's just come back at 10. This will take 13 minutes.
这个在多本科学的路上就讲 cognitive science，你知道，它就是讲的都是认知科学，然后要 bioscience 结合。然后呢，就让我找到什么两分，然后我想说就找三。也不知道是，因为第一节是我，所以我进去看。然后又找到这里很好，这里很好。那想要不要？哦，并且还开，10号思考短片，错错。没事，我也有认识的人要不要给他？测一下热。 完全不知道。是这样，10万。太累了，得看见这种不带脑子，然后我35都是做的。周一我早上9点到2点要做1啊。哎，你要选上了。马龙今年是对啊，种子也刷掉了，尔也刷掉了。不知道啊，他像个海王一样，这好多人面试，好多人都刷掉了。Someone like 是帮考试呀。不过上学期有很多人 rehire， 上学期基本上就是想留下来的都被 rehire。但是走了5个人，走了2个 MA 的，走了3个 ITP 的。我操，5个人我们可能还有很多其他人吧，我居然错过了台词。没有，他可能是星期一到星期天，然后星期一到星期五是一天3个人，那么就15个排班嘛。然后周六周日是2个人，那么就是4个排班，19个，然后一人1周排2个，那么就要10个人。
我算一下，他大概面了35个，应该没有那么多，可能30.8、24个人。
其中，
我觉得也不至于吧。其实这个真的是谁都能干，完全是。
对啊，对啊，不能这么讲究。我上学期被骂了，我指名道姓的骂，说什么我一般不喜欢骂人，但是先礼后兵，懂吗？先说我不喜欢骂人，但是我必须指出你的错误，以便你以后的发展。我操，这么帅这节课。
不是他那个班长，他讲1个半小时都没听我讲完，好像在讲。
这就是很政治正确一课。
正确啊，他就是不正确，他要做一些正确的事情。我就太敏感了，我讲什么绝对。
那个 blessed curse 的 translation 吗？
但那个最近有没有科研？5个学校的有康奈尔还是
泰还是康奈尔？
不一样是吧？
康奈尔泰克他那个校区在罗斯福岛上，就在纽约。
难怪都说是纽约。
建的还挺帅的，其实。三不养老。你们出题还真的是牛逼。真羡慕不能跟人带起，但我只能买面包。不让我吃面包，突然想吃 Danish。
我还想要个火虾面。 下午还有
家有这么近，太羡慕了。就肯定我们上次吃面的那个地方，从上走很远吃面的那个地方，就那家面比较硬那个当过，好忘了，但很近，就一直往那边走就到了。难怪每个人骑自行车上来。
好像跟课时间撞，后来我也对，我今天晚上去。
咱们要上多少分
60分
？60整。
一学期18周，学期8看不了。而且 summer 实习还占4个学期。
你上3了吗
？summer 你实习必须报课呀。
哦。
妈，实习就那么点工资，还要交3000块钱学费。是3天吧？3天3500我记得。就那么点工资，你还要交3500学费，等于没赚。我记得是3天。对啊，血亏。
你找到了吗？
还在找啊。
有 OA 吗？
被拒麻了。
你想是什么样的？
都行。
creative 的还是 coding？coding
多一点。毕竟我这个人没什么 creative。
收到 OA 了吗？我感觉 intern 应该会好学一点，我还没看。
好痛苦，我已经被拒麻了。
今天早上起来。
我是直接这个井喷式巨星，一天收到4封。对啊，大开了。啊，确实，但是你不停 sponsor 你 OPT 要怎么搞？你 CPT 要怎么搞？
这公司都吃不了呗。
对啊，就很多公司只要我一天 sponsor，他们就不要我，他们就直接自动点我前脚申请后脚去，我上午投下午去，我操！太他妈快了！
我觉得你的岗
然后他
没办法，他
1天2课。
最后一个学期。
最后一个学期
我就弄 part time 就好。就搞个在学校晚的课，然后重点在外面。
你怎么算不明白呀？总共18乘以3。
54啊。
最后学期。
6个学生part time。
12分是
6分，12分是full time。
哦，是。
啊？哦，对，6分往那一分。我天，12分。
对，6分是底 bottom 对吧？对，12分是。
12分是 full time 的有限。
对。
然后12分是。
就是11点往上都是 part time。
对，但是你要教那么多学生，你11点就只少了7、8。它是每一科，就是你6分以上，不忘多少钱。然后它12到18分高，是你交到了12分的钱，10到18分也高。
I just like就是优惠这 week to feel better. And so
下一期下期我要抱着米兜里哭，再给点奖学金吧。没有提哦，他那个方面上有提我操，我们那个方式挺大的。
Yeah, it was
就是在做更大的，顶到那个地方。我要做一个大变活人，然后你一进去人会被压成肉泥。
Yeah, it was one of those things where I feel like there was no expectation. I thought until I actually worked on it.
着急的一定是德军的有革命干将。
At least in my head, I put no expectation on myself.
种族优越感在你身
Because I
上
was
体
like, I
现的
need
淋
this
漓
time
尽
until
致。
it's really just like, you know,
we didn't do anything when they felt guilty about it. And I didn't even.
I didn't feel guilty today.
I know, but I finished it all time, so.
Yeah, and for me, it's like, I've gone.
哎呀，太棒了！我正好这个没同学，
Yeah, yeah,
太完结
That's not a
了。
problem.
yeah. And actually,
你不会又推
I
荐一个
don't
没
know
完
if
结的
it's
吗？
not in your school, but like in my undergrad, like, had like a big project, so I know it's gonna be fun.
Yeah, for undergrad, but I mean, like, I feel like I do major projects for clients.
Yeah, yeah.
Oh, that's like what I do.
Yeah, yeah.
It's like do physical design for clients. That's like,
It's gonna be okay.
yeah,
We
Yeah, but
deserve
also
to
some
rest.
basic
We had a
I- that's what I said. So I was fine with it. But,
收藏。
you know, but what's interesting is like, I had, you know, we had to put those 3 slides up that said, you know, whatever. And Sarah was like, oh, so you thought a lot about it because you refined the way you're talking about it. I was like, maybe just like having the break allowed me to like speak about it differently.
Yeah.
So I'm like, okay, cool.
Yeah, actually, we didn't need to do slides, actually, we didn't talk about it.
Yeah.
I made some
我
changes,
喜欢看，我一般看小说吃咖啡
but
的
other
频
people
道。
just said, I rested it. Why you did it?
Yeah.
You can say something.
Yeah, it was.
All right, let's get started
我
again.
还记得，我操。
All right, so these are the images I generate. So we'll go through them one by one. So this is coffee is hot. This is I can't sleep. I'm hungry. In the dark, will there be singing? It's cold today. Standing in a field of bones, my eyes wander to the blood red sky. The grass is red and the moon is orange. And the tree was covered in owls. So I also generated a couple of my own, which is one of them is a yellow car on a road. So we'll just leave it at that. So remember, this was the state of the art model as of a year ago. What do we think about these results?
What are the data input?
Yeah, so let's talk about that in just a minute, but just tell me what you think about the output.
Sure. They're images.
Yeah, they're images, yeah.
It looked like there's ritual aspect of it, so like really grainy and like blurry like that.
Yeah, grainy, blurry. The other thing is, you probably can't read this, but the images themselves are 256 by 256 pixels. So what else? What other thoughts?
Reminds me of a stop motion animation.
Okay. Of the images that turned out okay, what would you say is an interesting fact about them, or like, what do you think is working well and what isn't?
The images.
Yeah, of course,
Like,
yeah.
That one for sure, I wouldn't say like it works. It's like a back Photoshop.
So this is coffee is hot. This is I can't sleep. I'm hungry. In the dark times, will there be singing? It's cold today. Standing in a field of bones, my eyes wandered to the blood red sky. The grass is red and the moon is orange. The tree was covered in owls. Oh, and this is another one I did. There was a red dog in the park.
Seems like the shorter the sentences, the more complicated, or like the more sensibly complicated.
Interesting.
I met when I'm standing in the phone, it looks a little bit like a word.
Yeah.
It doesn't understand what words, what descriptive words go with what objects.
Yeah.
So like the blood red moon, it just put, or sorry, the orange moon, it just puts some orange somewhere, but it doesn't, and it got like the grass, but it doesn't get that there's another object and the orange is what's describing it.
Yep.
Or like the tree is covered in owls. It's kind of puts them together.
Yeah. Yep. Has anyone taken out any of Allison Parrish's class here? Yeah. Okay. Do you guys know a little bit about how like the text encoding works? Did she cover that at all?
Taking a class right now.
Okay. All right. So you just started. Yeah. Okay. Cool. So if I were to tell you, I have this machine learning model that can convert any text to any image. It's going to be groundbreaking. It's going to change the world. And this is the result I give you. What would your response be? Yeah, not very good. So this is kind of the reality of machine learning, and it's getting better every day. We'll look at another model today, and we'll actually see that like it gets really good. But even a year ago, this was state of the art. And like this is kind of the challenge of machine learning is you're going to hear a lot of people tell you like, oh, this thing can do this and it works really, really well. And you'll be like, yeah, that sounds like bullshit. And you'll see the results and it looks like bullshit. So part of the challenge with machine learning is you kind of have to lower your expectations a little bit, or you have to learn how to work within the parameters of the model, right? Like I think someone said this particular image looks very Monet-like, right? Which if you want to generate non-Monet-like images, this is going to suck. But if you're like, okay, I can work with that, I can make some Monet-like images, you can sort of work within the grain of the model. So I think your question was what data set is trained on. This is trained on a data set called COCO. We'll talk a lot more about data sets over the next couple weeks. COCO is, I don't know, one of the O's stands for objects, meaning that it's really trained on objects. And the way this is trained is that it takes images of objects, and someone, probably some poor research intern, wrote a bunch of captions for each image. And the way the model works is then it can take, it sort of looks at images and it looks at the text, and it does some stuff like that Alison Parrish does a lot work with, which is text encodings, which basically takes a bunch of text and puts it in like a two-dimensional space. And it says, okay, over here are a bunch of warm colors. Over here are a bunch of objects. And then it can sort of like reassemble. Basically, a lot of machine learning is you give it what you want. It tries to learn all of the associations together, and then it tries to build off of those. And it uses that association then to build images. So you'll see, right, like one of the things here is like, when it said red or orange, it understands where red or orange is. So we'll put red or orange here. But it's never seen red grass, right? Like the thing is, reality doesn't have red grass, or most of the time it doesn't. So it doesn't know what red grass looks like. So it's never able to associate those two together. And this is one of the challenges of machine learning is you kind of have to unpack how the model was trained, what the data set was. So then you can go back and be like, okay, how do I work within that parameter? Or how do I get weird and like throw something weird at it and get weird results out of it? So again, this was state of the art a year ago. Thank God we are no longer there because it's way, way better now. But it turns out the way to make things way, way better, which we'll talk about when we get into data sets, was they just trained a shit ton of, like, so COCO is probably 5,000 images, 5,000 images and 5,000 captions. This model called CLIP, which sort of does a similar thing, is trained on probably something like 5 billion images. So you just massively scale up the data set and it happens to work better. The challenge with that is you don't know what data is in there now. You don't know what it's been trained on because it turns out that it's trained on Reddit. So there's a lot of racist shit in there. So we'll cover more of these materials as we get through class, especially when we get to data sets, because data sets are basically the the backbone for a lot of this stuff. And how you approach a data set is going to dramatically change how your model operates. So we'll cover a lot of this. I just think it's a fun example to sort of say, like, let's start by lowering our expectations for what we're going to get out of this class, which is kind of a bummer for me to say that in the first week of class, but like, we do kind of have to learn to play within the parameters of the models that are given to us. Sometimes that'll be disappointing and sometimes it'll give us really interesting results. Okay. So let's just talk a little bit about just sort of the basics of machine learning, because I think one of the challenges with the space, as I mentioned, is that there's a lot of hype, and that hype often doesn't meet reality. And then we end up in a place where, like, anytime we say anything, people will like call it out as bullshit. So often when people talk about machine learning, they talk about this. They talk about computers and machines taking over the world. I assume everyone in here knows what Terminator is. Okay, if not, it'll make me feel really old, but anyway. So they talk about, like, you know, like Elon Musk is famous for saying like he's afraid that computers are going to take over the world in 50 years or some other bullshit. And so this is what ends up being the way that we talk about machine learning and AI in the media and other places, right? We talk about like, oh, these things will do all these things in the next 25 years. And the reality is it's just not true. So when people talk about robots, supercomputers, other things, they're generally talking about what we would call general AI, or AGI. You might see that referred to as AGI. I don't know anyone who isn't like totally high on their own supply that thinks this is the reality. We've been saying that AI will exist in some like human-like capacity for like 100 years, and it's always 25 years away. And the reality is it will always be 25 years away because it's not really going to happen. What we're going to talk about this class is a concept called narrow AI. And narrow AI is a thing that does one thing really well or moderately well, or maybe just tries it. So we think about that text image model as an example of narrow AI, right? The idea of that model, whether it's good or not, is you can input text and it can output an image. That's it. So really pretty narrow constraints, even though that's like kind of actually big.
AlphaGo.
So what's that? Yeah, like AlphaGo, like it's a game, right? It can play a game, which is not to say like it can play every game, or it can think like, a human and therefore like, make up games, right? It's very narrow. And that's gonna be a really important thing as we think about this, right? Because we might want to have a model that says, can I convert human faces to dog faces, right? That's like a very narrow challenge. And there are models that could probably do that. That's very different than saying, I want to be able to take a human face and make it look like any other animal in the world. That actually would be maybe a solvable problem, but it would require a lot of data. It would require a ton of like sort of setup. Or it's not to say like, I can take any face and turn it into any image. That's a much bigger problem. So as we go through this class, like a lot of what we're going to talk about is like, what are you trying to achieve? How do we break that down to the most narrow thing possible? And then how do we find a model that does that for you? So this is a very kind of famous model. It's called horse to zebra.
Nice.
And it does one thing. It converts horses to zebras. This is probably about 4 years old now. So you can actually see it's not really great. Like if you look here where the fence is, you'll see it like kind of doesn't know how to interpret the image of the fence around the horse. But otherwise, like 4 years ago, this was fantastic looking. And like the reality is it does look pretty good. Like compared to that attention GAN model, the text to image model, like the zebra stays within the bounds of the horse, right? It doesn't like, it's not like going off into the space. Another thing you'll notice is that all the background is slightly desaturated. That's because horses are mostly seen in not the desert, but like in African backgrounds where it's more like darker colors. So another thing you have to worry about is what sort of like what you might call leakage into your model also existing, right? It's sort of learning that like also zebras live in an environment that is slightly browner than the horse. So it's also doing other things to your image. And this is another thing we'll see happen quite frequently. But this is a pretty good example of like how narrow of a result can we get, right? I probably can't convert dogs to zebras, right? Because they're not as much the same shape. I won't show you this image, but if you Google, I think if you Google Putin horse to zebra, you'll find a very freaky looking image. A lot of stuff gets into like very creepy territory very quickly. So someone tried to take this exact model and put a human in there, and it converts humans into kind of zebra-like things. But again, it's a very narrow result. It's a very like, I want to do one thing, and I find a way to get the model to do that one thing. And even that's not perfect, but it gets me pretty close to that example. So that's a lot of what we need to think about and how we want to approach projects in this class. So the basic ML process, which we will be doing over and over and over again in this class, are the following. So we're going to need to make a data set or build a data set. To start with, we'll use a lot of data sets that already exist in the world. Horses, zebra is one of them. We'll train our data set, or we'll train a model on our data set, and then we'll do what we call testing or inference, which is actually the image generation, video generation. So data sets. So you'll hear, obviously within the world we live in, we hear a lot about data. We hear a lot about, how big data has changed the world, those sort of things. A lot of people think about their data as like, my data set is what Facebook has on me, right? And that's kind of true, but like actually what we need to think about is more of a generalized data set. So, one person's data that Facebook owns is not really actually really that important to Facebook. what is important is that everyone in this class is a data set that Facebook has, and that I can take all of your ages and all of your locations and then say something about, you as, people in your mid 20s to 30s in New York City are probably going to NYU, right? Like, so the main part about data sets is that we actually need a bunch of data that is similar to each other, right? So maybe it's everyone's ages or everyone's addresses. Or in the case of something like horse to zebra, I need lots of photos of horses and lots of photos of zebras. So in this class, we'll mostly be working with image data because we're generating images, right? So it's like, again, you sort of think inverse process to get to a new thing. So like if we want to generate text images, we need to get a bunch of corpus of data of text and a bunch of images. So similarly, like that's how we need to think about this class, right? So if I want to create a bunch of dog faces, I'm going to need to actually find a bunch of dog faces in real world. So building a data set is the most annoying part of this process because you need a lot of data. So remember I said that the text to image model we looked at used probably like some like 5,000 images and 5,000 captions. And then what worked really well was actually 5 billion. Now I'm not going to go and ask you to find 5 billion photos of dogs, even though you probably could on the internet these days. But we do need to get to like 500 or 1,000 or 2,000 or 5,000 images. And it turns out that actually is really, really hard. We can't just go and download one image at a time. It's going to take us forever. So we'll look into like doing some web scraping. We'll look into finding pre-made data sets, how to like automate some of our processes, those sort of things. So data sets are the hardest part of this, especially because a lot of us are going to want very unique outputs, and that's going to require unique inputs, and unique inputs are hard to produce. So we'll talk a little bit about some techniques to get there, but data sets will hands down be the hardest part of this class. Once we have our data set, now we can start to do what we call training. That process involves a data set and what I will determine as a model. You're going to hear me use model interchangeably between the model we have trained and the model architecture that we're using. That just happens in the world. So if you hear me talk about style GAN as a model, there is a style GAN architecture, which is all the code that's written for it. But there's also a style GAN model that you will get out of the end of your training. So it's a little confusing. Just know that both words can kind of work for either. If it's ever confusing, just ask me and I can sort of be like the network architecture or the output model. So you do this training process on the GPUs that we have or will be using. It's going to depend on what model we're using or what architecture we're using. For something like style GAN, it can take 2 weeks to train your model. So again, stuff is slow. You have to plan ahead and you don't want to fuck it up and then have to redo your data set, those sort of things. So we'll be looking at just like, we'll be working through things in the first couple weeks of class, just to get sort of a handle on how the process works, what we should think about, so that the next time we want to do it for our own models, we're not wasting a lot of time. So go through this process called training. Out of this training comes what I again would describe as a model. This is essentially a little package of code or like weights. We'll talk about more of what that is in just a minute. But this is our horse to zebra. What this thing says is I know how to convert a horse image to a zebra image. This is our architecture, which says how do I learn this process? If you're interested in learning exactly about how a neural network works, we won't really cover it too much in this class. There's this really great series from 3 Blue, 1 Brown that is all about how neural networks learn. I highly recommend it. It's like an hour to watch all the videos. So once we have our model, that cube that I'm calling it, that model can only take in a certain input type and only output a certain output type, right? So if I've trained a text to image model, the input has to be text and the output will always be an image. If I've created a horse to zebra model, my input has to be something that is horse-like as images, so I can get out a zebra image. So it's also really important that you learn what your input and output are for each of these models, because you might say like, oh, I want to generate a horse to text or a horse to zebra image, but I want to have the input as text. Well, then you have to pick a different model architecture, because other ones are only assuming you're going to give it images as inputs. If you want to create a text to zebra output, like you would need something different. So just be aware of that. So it's going to be important to remember what your input type is. In some cases, it'll be an image. In some cases, it'll be 2 images. So horse to zebra can actually be a horse and a zebra image. Is that right? Yeah, I think that's true. Or it could be a horse image only. It's a little confusing in that regard. But let's say something like style transfer, where style transfer takes in a content image and a style image. So you need 2 images for that model. So you have to sort of remember what your required inputs are. That gets then fed through the model, and out of it comes, in most cases in this class, will be an image. Maybe, so for like video, you often just do this multiple times to generate every frame of your video. So there's
Is that
very,
how the
go ahead.
Video was made, like, it was frame by
Yeah.
frame.
Which is why if you look at it, it's a little flickery, because we'll get into this when we talk about video, but most of these models that are just single images have no concept of what the image before it looked like. So there's no optical flow. So that's why if you watch that video, you'll see it's a little flickery.
Why isn't there a way to do that? To learn from the previous one as well.
There is a way to do it. It's computationally more expensive.
Okay.
So a lot of people just don't do it. Yeah, optical flow is like a big part of video input, or just like smoothing. So you can like sort of get some better results out of that. It's one of those trickier things that a lot of people just don't. The other thing I should mention is that a lot of these models are made by researchers at like a research lab. They're scientists, they're not artists. So they don't really care about that result. They care about the fact that they're able to convert a horse to a zebra. They don't care about the fact that like the video is flickery, right? So, yeah.
Right, but in the horse to zebra model, if they are all independent, the stripes would be different as they claim to, and they were the same.
Yeah. But there's still a little bit of flicker, right? There's still a little bit of flicker. And that's because that gets into some other stuff. We'll talk about more about that model a little bit later in the following weeks. But yes, you're right that like the actual larger parts of the stripe were fairly consistent, but there's still a little bit of flicker there, and that's just because that model only ever generates. It's getting ahead of ourselves, but if you send the exact same image to that model every time, it will always get the exact same output. There are other models that are not deterministic like that. So because of the determinism, it will always output the same, which means slight changes in your image are going to give you slightly different results, but mostly the same. So again, that's another trick or like thing to be aware of when we get into more of these models is like, do you want a deterministic output, meaning your input and output are always the same? Or do you want to inject some sort of randomness or variability or be able to change things? So you can always feed in the same input and get out a different output. So again, all these models have slight different variations, and this is where we need to like sort of understand a little bit more about each model before we start using it. So this class is called Making Visual Art with GANs. It is probably, well, I'll get to this in a minute. GAN is an acronym. It stands for Generative Adversarial Network. Next week or the week after, I'll cover exactly what that means. All 3 of these words are very important. The network, as I mentioned, is an architecture structure. So it's more about how it's built. The important thing is for this class is that we're talking about generative models. So a generative model, as you might expect, it means it generates something new. The opposite of this is what we would call a discriminative model, or what you might hear referred to as a classifier. A discriminative model says yes or no, or like this belongs in this class of objects, right? So like, I don't know, a good one would be like animals. Is this a horse? Is this a zebra? Is it a snake? Is it a lion? Right? So that's a discriminative model. And you give it an image, it can give you a class or like a topic point out of it that is different than saying, I want to generate a new snake, I want to generate a new lion. And actually, this may be the last time I use GAN title in this class, because GANs are kind of falling out of favor right now. In part because they're, we'll talk about this why, but like there's now a bunch of different generative models, and all of them have different sort of pros and cons. So you might hear people talk about GANs. If you took Gene's class, you probably know about variational autoencoders, which is called VAEs. There's also these new things that are called diffusion models. All of these are sort of like the new hype. But the reality is that they all have certain benefits and certain downsides to them. So we'll definitely talk about those as we go through our models. But yeah, at this point, like GAN is just one particular model of many, and we'll look at a bunch of other ones in this class as well. Cool. So let me just talk through a little bit of some cool projects you might want to look up, or some artists you might want to keep your eye on, and sort of dig through. One thing I want to make very clear is that we're going to talk a lot about techniques in this class, right? We're going to talk a lot about, like, you know, how do you generate images using style GAN? How do you generate images using unit or cycle GAN or other things? But the thing is, and I'm sure you already know this, especially at ITP, but like a technique is not art. Every single model that we will work through in this class could be artistic in the right lens or the right hand of the artist. And that's what's really important about teaching these classes to artists, is that it's all about the artwork you're trying to make from it, not the model itself. So this is one of my favorite phrases from Alison Parrish, and she says, "Asking, can a computer generate Shakespeare, to me is less interesting than asking, e.g., what would Gertrude Stein have made with TensorFlow?" If you're not familiar with Gertrude Stein, she was like a very formalist, sort of like experimental writer. And this gets to the heart of this, which is like, you will hear a lot of people talk about, like, can machine learning be, can machines make art? I don't really care. Like, I'm not interested in a machine. Me personally, I'm not interested in a machine making art. I'm interested in what each of you as individual artists can make using machines. What is unique about your artistic point of view, or what is unique about you as an artist? How do you use the materials available to you to make interesting art? So again, each of you is going to have your own point of view, your own interest in data sets, or your own interest in sort of, maybe some of you want to do video work. Maybe some of you want to do real-time exhibit work. Maybe some of you want to play with hardware and you want to try to figure out how to integrate these things. That's what's interesting to me about this material, is less like, you know, oh, all of us are going to make our own style GAN model in this class. Okay, whatever. More about what are we trying to achieve and what's the right model to match that, right? So that's the point of this class, is like, I want you to think about, like, here's my vision for what I want to make. How do I get there? And I'll help you work through that. Yeah.
How much control do we have of the final? I don't know. It's kind of
Yeah. The truth is, it's a little bit of back and forth, right? You might be like, okay, I want to do something in this space, and you find what models are available to you there. And as you look through, you're like, oh, they all have the same kind of look and feel for an output. Okay, well, then the question becomes, do I find a way to leverage that in my own work? Or do I find a way to break that? Or do I just choose something else? That is the challenge of this space, is that because we won't be building our models or like building our architectures in this class, we're going to have to deal a little bit with like what's sort of available to us, which means, you know, we might have to do a little bit of massaging. The other thing I would say is that in my experience, if you you may want to chain a bunch of these models together, right? So you may find that this model does this model does this. If I combine them and I start here and then I, you know, train on one model and I train on another, I can get a unique output by sort of like combining multiple elements together. So that's definitely going to be part of this class, like trying to figure out, like, okay, what am I trying to do? How do I manipulate these things in a way that still like looks unique, or like is doing something I want to do with it? So I've got some like very basic examples of like, here's some topics or like things that I sort of see happening across the space that I think are interesting and worth us thinking about. The first is, a lot of this stuff is just very psychedelic. So this is a guy by the name of Alexander Mortsev. If you've heard of Deep Dream, Alexander invented Deep Dream. This is not Deep Dream, this is style transfer. But it is still really interesting in the sense of like, we're able to take pictures of humans and apply some textures to them. This is style transfer, I believe, probably, yeah. So we're able to generate some really interesting textures. A lot of stuff looks psychedelic because computers are weird and they always do lots of RGB banding colors, so you get really weird results. This is Ryan Murdoch. He was actually probably the inventor, I don't want to say inventor, but he was one of the leads in sort of the newest experimentation with text to image. So, you know, again, you get a lot of these trippy colors, you get a lot of eyeballs, like other weird things in outputs. So this is text to image. So he was able to feed interesting text to these models and get out weird images. This is some of my own work. So, you know, one of the things that we talk about, like one of the things I think is really interesting about machine learning models is you're able to generate video from these things fairly easily. And if you take a lot of static images that are only normally seen in stasis, and then you're able to actually animate them, you get this very like psychedelic, like all of a sudden the wallpaper is kind of moving on you. This is a stallion model.
May I ask what data set did you use? Like what?
Yeah, it's a custom data set of sort of wallpaper, like Chinese and Asian influenced wallpapers.
Or reflective.
So surrealism is also a big topic within this. You'll see that a lot of this is like, because our models aren't good at actually giving us realistic images, we kind of like lean into that, right? So like, give me weirder shit. So surrealism is often a common topic. Sophia Crespo is a really amazing artist who does a lot of stuff with machine learning. These are actually, I believe these are GAN images that she then printed in cyanotype. So again, this is also an example of like, the computer model probably looks like one thing, but by printing it in a cyanotype, you get a slightly different result, right? Like all of a sudden this looks old. This looks like almost like eldritch horror, where it's like, where the fuck did this thing come from? And how did someone find this in the 1900s, right? So like, again, there's, yeah, exactly, like creepy crawly, like there's stories to be had within this. And like, there's ways to manipulate these things in interesting ways. And I think like, the more you see other artists doing work like this, I think the more you'll sort of understand that like, the model, the machine learning model is not the end result. There's more you can do with it past that. Mario Klingemann, if you're not familiar with his work, I highly, highly recommend checking out his work. He's kind of one of the innovators in the space, I would say. This is a pretty old piece of work from him at this point, but it's still really interesting. So this uses something similar to do to horse to zebra. This takes face drawings of faces, like just static like wireframes of faces, and is able to manipulate a real image face onto it. You can kind of see that because see it's sort of flickery. It's just like the horse to zebra image. This is work from a former student of mine, Adam Picard. So what he did is he's actually a 3D artist. So what he did is he trained a 2-dimensional model on stained glass, and then he fed it through some of the 3D rendering tools to actually render it in 3D. So again, there's sort of this like, okay, I've got a thing that's cool in 2D, but like it'd be even cooler if it was in 3D and lit. So again, it's sort of taking these models and applying them in different ways. So this is just a style GAN animation, but then he like found a way to light and using 3D tools. Another person I highly recommend checking out, if you've never seen his work, is Memo Acton. Just a really interesting artist. I'll play a little bit of this. So this is the same model architecture that we use for horse to zebra, except what he's done is he's trained it on these cloth pieces and probably photos or paintings of the sea. So the model is able to learn like, hey, where I see yellow is where I should put waves. Where I see blue is where I should put sky. And let's see when this happens. And when I drop in my charger, I get rocks. So again, like this is doable within like any one of us could do this.
Is this live? No.
That's not live now. This is also 4 or 5 years old. You could probably do this live today, I would actually bet. You could probably do real time with this. Not the training part, but like actual output part. In fact, I know that he's done exhibits of this where there's actually like a webcam and you can play with it and you can see your output live on a screen. And he shows he's got a couple of different examples here, right? So he's got one for fire, which converts sort of his like other stuff here to fire. I believe there's another one here that's this is clouds. flowers. This would be a fun project to do again today because I bet you it would look far more realistic, which actually might be worse. I don't know. Because the other thing is like we're starting to hit that uncanny valley area where like it starts to actually look worse because it's less sort of impressionistic. So again, you kind of have to think through like, you know, what am I trying to achieve and what's the look of these things here?
And what would you make this?
Probably literally, this is CycleGAN, but it's probably literally a data set of just photographs that he took of these sort of positions. And then this one's probably like, I don't know, impressionistic flowers. And the model kind of just learns how to convert these two, which is kind of the beautiful thing, right? Like if you were to try to code this, like it'd be a huge pain in the ass, right? Like to have to do like all the shape morphing, like it would be a nightmare. But the cool thing is that these models can actually sort of just interpret it themselves. And they'll try to make the best guess they can, and often it works fairly well. Sometimes it doesn't, but like other times it does. And that's the power of this stuff is like, you can kind of just say like, hey, figure out how to translate this to this. And the model comes back and says, okay, here's what I did. And you're like, oh shit, I didn't need to write any of that. I just said, try to do A to B. That's it. Again, cubism is another sort of like popular sort of topic with these things. This is again work from a student of mine, John Gall, who trained on a bunch of sculptural models. And the thing about these models, we'll talk about this a lot more when we get to data sets. Most data sets want to be really well aligned, like they want to have sort of everything line up in the exact same spot with like very little difference. But if you throw stuff like sculptures at it, it like starts to like try to combine different angles and different like perceptions. And you get these sort of like very trippy sort of like cubist sort of direction to it. I'm actually not super familiar with this project, but I just sort of love the output image on it. And that you get this sort of like three-dimensional space and like these sort of like collaged effects almost in it. So as I mentioned, collage is another big topic for this area. If you've never seen the work of Helena Sarin, I highly recommend checking out her work. She is a like very prodigious artist, and she is mostly working with her own data, with her own art. So she'll do a lot of paintings herself. She'll take photographs herself, and she sort of combines these things, and you get really interesting outputs. Mike Tyka was one of the originators of Deep Dream and style GAN or style transfer and other things. So here again, you can sort of see, I assume this is like a style transfer piece using, I don't know, Kandinsky or some other one of those artists, Bauhaus era artists. This is a piece that is literally a collage. So what it's doing here is it's taking all of these images below and it's creating random props of it. And then what it does is it shakes them up and moves them into the different positions until it makes a face. So here we can play this again. So they start really weird and then they like move until like the model says that's a face. So body horror often, again, because these models are like kind of bad at certain things, people like lean into that. Body horror is another very common topic because there's a lot of models of bodies and faces. And a nice way to be an artist is to fuck those things up. This is a model, oh man, this is gonna get hard to explain because we haven't covered style again yet. This is a model where basically it is trained on human faces plus ukiyo-e art. Is that how you pronounce it? I forget how you exactly pronounce it, but Japanese art. So what's doing is at the bottom layer, it's basically like doing a combination pass. So it's got like the samurai warrior, and then it applies like a real skin tone on top of it. So it gets like kind of like creepy like that. This you might have seen because this is a really popular thing that happened maybe a year or two ago. Basically converting pictures of either you or celebrities into like Pixar style artists or Pixar style images. You know, when an artist started this, and now you can probably get this out of a face filter, right? So like that's the other thing is a lot of stuff just becomes immediately like adapted and like simple to do. But someone has to go and figure out how to make the model first. But with a lot of these face models, once they exist, you can bring them into something like a snap filter and actually then apply them as like a augmented reality kind of thing. This is another example of sort of being able to manipulate in a two-dimensional space. So just doing drawings and having that drawing converted to like a photorealistic version. This is probably real time. Robbie Barrett is another sort of like early creator of this space. This again is, a bunch of sort of Renaissance paintings of bodies. And my guess is that what he did is this is either a GAN where essentially he's like just recreating these images, or he's able to draw in a certain place and that gives you a skin texture of body in that place. Scott Eaton is another one of these artists. One of the things you'll also learn is that if you're really an expert in a certain area, like you can leverage your expertise to create really interesting machine learning models. He happens to be both a figure drawer as well as a really famous photographer. So what he's doing here and what it's looking like is in the background, he's got his sort of like pencil line figure drawing. And he's able to convert that into these really interesting body shapes because he's also been photographing all of these bodies in a custom way. So again, being able to make custom data sets also sort of like a superpower because you can like kind of control things a little bit easier. There's actually a link from this description is like a 45-minute video of him explaining the process for this. And it turns out that like, if you have really, really powerful control over your photographs, you can like manage lighting a lot easier. Really interesting. I would definitely recommend checking it out if you're interested in learning more about this process behind making these images. AI is metaphor. So basically, again, this is sort of like taking a model you trained, but then attaching other data to it. This is Anna Ridler's piece. This is probably 4 or 5 years ago now and probably is due for an update. She trained a GAN model on a bunch of flowers and then hooked it up to the price of Bitcoin. So basically, as Bitcoin's price rose and fell, they believe the flowers opened and closed or other things. So it's also helpful to know that like underlying all of these things are just a bunch of mathematics. So once you know what the math is, you can also then use other data sources to control various aspects of the model. So especially within GANs, which we'll talk a lot more about, there are ways to control various aspects of your images. So like, let's say you figure out what vector or what mathematic change you can make to the model to have the flowers open and close. You can then tie that to some other data source. So there's a lot of projects where like, you train a model to do one thing, and if you like move your hand from left to right, you can change aspects of those models. This is sort of my own work. So this is this happened during the Australia wildfires maybe 2 or 3 years ago. This is a model trained on flowers as well as Australian birds. And the concept here was like the Australian birds are sort of like disappearing through wildfires. So if you look really closely, there is a bird here. There are birds there as well, and you get sort of the skeletal structure of these things as well. Lots of people like to point out how stupid machine learning is. Again, like as we talked about in these concepts, like they're both good and bad, and like lots of people overhype them, and it's pretty easy to point out how silly that is to overhype these things. If you've never seen the work of Janelle Shane, I really, really recommend you check this out. She has a book. I forget what the title's name is right now, but it's a bright green cover. It's a whole book about how AI is actually really like not as good as we expect it to be. And her whole job is just to like go through and like make funny versions of these models. So what is this? So this is a model called Spade. What Spade does is, I'll play this in a minute. Spade will take an image you feed into it and try to figure out the shapes or outlines of various objects in it. So what she did is she fed in a Star Wars film. The film tried to guess, where the lightsaber is and like that sort of thing. She then fed that, which is like the sort of shapes and outlines, into a different model, which takes those color parameters or the color shapes and tries to generate new images from those. So let me just play this really quickly and you can sort of see what happens. So basically it finds human faces and it tries to convert those back to other faces. I think the lightsaber ends up looking like a baseball bat. So like it's trying to convert it to a baseball bat or other things. But this one's kind of interesting just in how abstract it is and just how like, impressionistic it is. This is what's called a super resolution model. We'll look at super resolution models as an actual tool for us to use. Because most machine learning models produce pretty low res images, we need a way to make those higher res for printing or for other purposes. And there's actually a whole superset of machine learning models called super resolution models. And their whole job is to figure out how to res up an image. So what Jonathan Fly has done here is he's taken literally low res emojis and fed them through a super resolution model, which attempts to do stuff like res up faces. So it takes, a Doom character and reses it up and you get a really creepy thing. This emoji, so fucked up. This emoji of the sweat emoji into like a creepy ass face. The pizza one is actually kind of good, except the pizza now looks like lips, or the pepperoni slices now look like lips. I actually think that woman is fairly good. That actually like fairly works well. But again, there's sort of like fun, like trippy, weird things you can do with these models. Super resolution models have actually gotten really, really good in the past couple years, to the point of where like I think it is actually like you can use them to optimize a lot of images. They work fairly well. We'll talk about those in class later. This was really famous maybe a couple years ago. I believe this is Edges the Cats. There's a web page where you go in and draw a cat, hit process, and it would output the realistic image of cats. Problem is when you put stuff on the internet, people do really fucked up things with that. So someone figured out you could draw like kind of a cat and get like a really creepy looking image out of it. So again, the whole purpose of this model is it's supposed to like, it assumes that with the best intentions that someone's going to draw like something that looks like a realistic cat. It's going to figure out how to convert those edges to a cat. And then people go in and do weird stuff with it. Another topic of this is like, we talk a lot about machine learning and the ethics of it and what's wrong or right about it. So a lot of artists will create projects that allow us to do this. Everest Pipkin did this really cool project where, well, I don't know if it's cool. It's cool in an output, but like it's kind of sadistic in its own way. She watched every hour of a machine learning data set around video, which is probably some like 2,000 hours of video, in the way of like, what does a machine see, or like, how do we think about these things? And it was very, very creepy. And then she made a project about that. It's linked to here if you're interested. A lot of things around facial data, again, because one of the solutions to making our models better is to get more data. People will go in and scrape a ton of data that is probably not theirs to scrape, but they'll do it anyway. So exposing.ai is about unearthing what images are in data sets and where they came from, and lots of face data. So like it's very likely that our faces are in some data set somewhere being used to train surveillance models, to do other things. And what are the ethics of using other people's data in your models? And this is the thing I just talked about recently, which is like, AI is just one step in another system. So you should think about how you can tie these things together with other projects, other things you're working on and interested in. This is an artist called From Fran. She trained a model on her own ceramics. And then she actually took the outputs from this model to create new ceramics from it. So I think somewhere in here, she said that like, for whatever reason, the model started to generate cups with 2 handles. So she just started making cups with 2 handles. So you can think about these as inspirational tools as well for yourself. Robbie Barrett trained a machine learning model on fashion accessories or fashion runway shows. And then he took some of the outputs to actually generate new clothing from it. So this particular runway show, what happened with this model is that it generated a lot of handbags attached to legs, but the handle disappeared. So he sort of took that and he made like a pant that then had this like big like package thing on it. He's done a bunch of stuff like this. He actually did a show with Acme a few years ago, where Acme actually produced, a wide range of sort of GAN-like clothing. This is a student of mine, April Sertiman, who did a lot of these sketches of sort of like, she would be on a vacation somewhere and she would, just sort of draw what she saw. So she trained a model on both her photos and her drawings. And then she actually stuck it to a pen plotter and had it redraw the things it was making. So I talked a little bit about faces being like a really popular topic within GANs. I personally try to avoid doing a lot of face work because I think there's some tricky ethical issues around faces, but there are a lot of face models out there, and we'll probably look at a couple of them in class. This is a couple years old now, but this was state of the art maybe 2 or 3 years ago now with faces. God, these look terrible now. I can't believe this is actually, well, at the time, this is really cool. We're in a much better place now. But one of the things that's sort of funny about face models is they're kind of cheating. It's actually really easy to do a face model, which might sound surprising, but the truth is humans aren't that different from each other. Like we all have 2 eyes, we all have a nose and a mouth. And as long as that data set is like sort of structured in a way that they're all aligned really well, it's actually not that hard to do face models. So a lot of these companies will put out a face model and be like, look how great this is. And if you've invested any time in machine learning and creating data sets, you're like, that's the easiest problem to solve, or like one of the easier problems to solve. But humans are obsessed with ourselves, so we end up like really liking faces and that sort of thing. So I'm going to encourage us to like try to avoid doing faces in class. If you have a really good idea or something you want to play with, like you totally can. But in general, it's kind of a solved problem, I would say already, or like there's lots of cooler other things you could play with. But we'll, if you're interested in it, we can definitely play with it in class. But I'll tend to avoid it when I do demos and things. Cool. So there's some additional inspiration. So there are lots of good like sort of machine learning workshops and other things these days. So there's some sites that you can go to look for other projects if you're interested in that. Okay, so let's do this. Let's take an 8-minute break. So let's just take a little break. And we'll come back and we'll wrap up class with Colab. We might not get through everything today, which is totally fine. So maybe I'll talk a little bit about Colab, and the next week we'll actually start to use it. Sound good? All right, see everybody in 8 minutes. All right, so let's go ahead and get started. People will come back in a minute. All right, so talk about in class, or I talked about earlier that we're going to be using Colab mostly for this class. As I mentioned, there is a cost to Colab, but it's fairly inexpensive, all things considered. So I'm going to talk a little bit about Colab is and why we're going to use it. So what exactly is Colab? Colab is a tool that's put out by Google. So we're going to all use our Google accounts for this. It essentially allows us to access Linux-based GPUs behind the scenes of a web interface. So as I mentioned, one of the challenges with doing this work is you usually need a Linux machine or a really high-powered GPU. Like $5,000 to $10,000 GPUs, which none of us probably have access to ourselves. I know they do have a couple at as a part of like the lab here at NYU that you could rent if you wanted to, but it would be such a pain in the ass to get set up that it's probably not worth it. Colab was sort of like, because Google is able to sort of like obfuscate all that stuff and just give you a nice web interface to use them. So in that regard, it's well worth the cost. If you think about $10 a month, it would take you quite a long time to get up to a $5,000 GPU. And that's not even including other hardware. So the cost is, because it's Google, is fairly insignificant, but it is Google, so you have to play that with all the data and other issues of privacy that would likely exist. I mentioned this previously, but these use a thing called Jupyter notebooks or IPython notebooks. So the interface for Colab is probably a little bit new if you've never used notebooks before. The cool part about a notebook is that it is a combination of sort of text and notes, but also code cells. So you can run a code cell in addition to taking notes. So it's really powerful. A lot of data scientists use it. A lot of people who do data science work or teaching, it's a nice teaching tool because you can add lots of notes ahead of time. So what I recommend you do is I'm going to share links to notebooks because they're on Google. They're just web URLs. You can open them. You'll make your own copy. And I highly recommend that when you make your own copy, you also take notes for yourself. I will try to add notes like in any of the major notebooks we use in class. I'll make sure that they should be fairly well documented. But you should always add your own notes because things that you might get tripped up on or things that I might not explain particularly well, like maybe you want to take some notes just so you remember that yourself. As I mentioned, there is a free version. The free version is going to give you the crappiest GPUs, which are still really nice. They're a couple years old, they're slow. So for a lot of the work that we'll do in the first couple of weeks of class, they're totally fine. So you don't need to pay for Colab until you're ready to, until we're probably going to start training our own models. So that probably won't be until week 4 or 5. So I definitely recommend like save your money. Don't pay for it until we need to. But just know like I might be in a demo in our class, I might be using a high power GPU, which will mean it's faster, which means if you try to follow along, you might fall behind a little bit, but that's probably fine. For a lot of your homework, I'm just going to ask you to play with notebooks and like, run them. Most of them will run fine on the slower, crappier GPUs, but you might run into 1 or 2 that like have issues with RAM or out of memory issues. You could just skip that notebook if you want to, or it might be time to start paying for Colab Pro. So just be aware of that. I would say in most cases, you'll probably be fine. So if you are very budget conscious, definitely you don't need to pay for it until we're really ready for it. Students in last year, I had some students that never paid for Colab and they seemed fine, but also as a 7-week class, they never had to like make their own models or like really do their own work. So there's Colab Pro, which is $10 a month. Then there's Colab Pro Plus, which is $50 a month. And you would say, man, that's a big leap. But with Colab Pro Plus, you'll get really, really powerful GPUs, like the brand new models that cost $10,000. So it kind of, again, it pays for itself very quickly. So if you want to get that, you can. There's some other nice benefits of Pro Plus, but for the most part, you're probably going to be fine. Actually, one of the reasons you might want to get Pro Plus is because you're able to run notebooks in the background. So if a lot of you are traveling a lot of times and you shut your laptop, one of the downsides is that when you shut your laptop in Pro or Colab, the free version, your model might stop running. So especially when you're doing stuff like training, you might actually want to either do that or there's other ways around it, right? Like you could, I think actually Pro probably works fairly well. If you're just like traveling really quickly, like, running between classes and you keep your laptop open, it's probably gonna be fine.
For
Yeah.
the free one, is it if you have a set, if you change the tab, that it also doesn't run?
I think it should run in the tab, but you have to keep that tab open. The other thing is that the free version, you also can't access the command line at the same time you're running the GPU. There's lots of like little like crappy things that the free version kind of like handcuffs you with. But I would say for the first couple weeks of this class, you'll be fine without it. But you probably do want to pay for the Pro at some point. So as I mentioned, there's a free-ish version of Colab. The other nice thing about Colab is this text and code portion. We'll look at that in just a minute. It allows for a little bit more note taking. So if you aren't particularly familiar with code and you have trouble with command line commands, you can take some notes for yourself. So actually next week, I know, at least in the class that I taught last year, a lot of people didn't know like really basic command line stuff, which is going to be a hindrance for you. So next week, I'm going to do a really basic command line intro for anyone that's not familiar. So we'll do some command line stuff. In my experience, like knowing even just the most basic command line stuff can save you a ton of time. Like learning how to write a zip command, how to zip up a file from the command line, how to like search folders, how to navigate them, that sort of thing. It's going to save you a lot of time. So I know like the command line can be scary for a lot of folks, but it really is like super powerful and it really will help you, especially when you get into Colab as well as just sort of doing stuff with servers, because Truth is, the GUIs are all really shitty, but if you can use a command line tool to get what you need out of it, they'll save you time and it makes it a lot easier. So we'll do that next week. The other thing I really like about Colab is it comes with all the package dependencies you need. The biggest pain in the ass about machine learning, trying to run it on your own machines, is that half the time you have to install the exact right version of something, and if you don't, it all breaks. So Colab does a really good job of actually sort of like obfuscating all that, like hiding it. It just, half the time it just works out of the box, and the other half of the time I can probably help you. But it saves you a ton of time because installing all this shit is a huge pain in the ass. So it's definitely worth it. I would say after this class, if you're like really excited about machine learning and you have the ability to run your own Linux machine or set up your own GPU, you might want to make that leap because there's some benefit to it. But for the most part, it's way better to just use Colab. Because they're web URLs, we can easily share them. So you can make your own notebook, make edits, and then share it with a friend. Really easy. You can build little GUIs within Colab as well. So you could potentially make a cool little web interface, and as long as you give people some direction on how to run a Colab notebook, pretty much anyone could run it. The downside is that there are time limits to Colab. So if you don't run like if you're not running a background execution for a while, the machine will shut off and you'll lose your work. There are max time limits. I believe the free version of Colab can only run for 12 hours at a time. Colab Pro, I think, gives you 18 hours, and Colab Pro Plus gives you 24 hours. That's actually gonna become a big issue when we do training, because training can take weeks. We've got some tricks to get around that. But for training, a lot of times the pain in the ass part is every 24 hours you have to like restart your notebook. Not actually that hard, it just, you have to remember to do it. So time limits will become a big issue when we get to training. It's probably less of an issue for most of what we're gonna do in the first couple weeks, so just like playing with some models and generating some images and video. So just be aware of that. That is basically because Colab doesn't want to make this so cheap that anyone can do it, or like crypto miners can use it. So that's pretty much why it exists that way, or why they have time limits for it. There are some GPU and CPU limits. Again, this is largely based on what price you use or what price point you're using. If you got the free version, stuff's gonna be slow, like just it is what it is. And there will be some memory limits. You might get a lot of memory errors, especially on the really crappy 12 gigabyte GPUs. But I very rarely run into these issues. And obviously, like within this class, I can probably help you get around any of them. And lastly, it is a Google product. So just beware of the issues that Google is probably tracking everything you're doing. I don't think they really care what you're doing in notebooks, but you know, it's a part of that. I think all of us at NYU have Google accounts anyway, so we're kind of screwed no matter what. So you know, just be aware of that there are some potential issues with using Google tools. The big thing is just that it's going to be cheap for us to use this. It's so much cheaper than renting. If you were to try to flex for the $10 a month version. So I know money is always tight for grad students, but like just be right, it's so much cheaper than the other options out there. You just really can't compete with it, which is why I recommend using it. Also, it's cheaper than Runway. At this point, like Runway is so expensive too that even if you try to just do it in Runway, it would be more expensive than Colab. Okay, so here's the pricing with Colab Pro. It's actually now available outside the US, but we're all here, so it doesn't matter. You do get 20 hours of runtime, and you get a chance at the good GPUs, which are the P100s or the V100s. I'll explain what that means in just a minute, but basically there's different versions of GPUs. If you pay for Pro Plus, you also have the chance of getting an A100, which is really, really nice. But again, it's probably not really super necessary for this class. Right, so let's see, we got 15 minutes. So I'll quickly run through the demo I'll do the basic demo, and then I think next week I'll pick up on S2ML, which is a text-to-image model. So let me just quickly walk through sort of what a Colab notebook looks like, how you run it, that sort of thing. And then next week we'll pick up and have like more fun with stuff. So what I would say is you probably don't need to open this, especially because you don't have the slides. So just watch me walk through this. And then next week, what I'll do is I'll make sure everyone has links to the slides ahead of time, so then you can actually walk through the process with me together. So this is what a Colab notebook looks like. on this tiny screen, I made it really big so you can read it. But I'd probably recommend changing your font size a little bit. So a notebook along the left-hand side here are a bunch of functions. Because this is sort of built a little bit like Google Docs, there's a nice table of contents. This will become really helpful when you have really, really long notebooks. This will allow you to jump around into different places to run different things. There's search, which we don't really need. There's a snippets function. I'll talk about snippets next week. It's probably helpful to grab the snippets code that I have so you can enter in little things like how to sync up a Google Drive, like those sort of things. The function that or the folder, I guess the view that I'm mostly used here in these tabs is the file view. The file view is great because this is where all your files are going to be. So just remember, this is running on a cloud server behind the scenes. You can connect this to Google Drive, which is actually really, really helpful. We might look at that in just a minute, but I highly recommend that in this class, you always connect your Google Drive account to your Colab notebook. It's just easier. You can save stuff directly to there without having to remember to download it. If you save directly to Google Drive instead of saving to your local notebook area, it also means if your notebook does shut off, you don't lose all your work. One of the challenges in this space here is where it'll save files and things. If stuff gets saved here and your notebook shuts off, you will lose that work. So make sure you back up your work, make sure that you're saving things directly to Google Drive if you can. I'll cover that process probably more next week. But it's really important to know that if you're in this folder area, the files here are not yours. You don't own them. They're on a server, and that server will get shut down and you'll lose those files. So just be aware of that. So that covers this area. The most important thing, I'm actually going to shut this down and show you what it looks like. So when you first come to a notebook, at the top here on the top right, it will usually say connect. So until this is connected, you're not connected to a server or a GPU. So you actually need to come in here and hit connect in order to get connected. When you open the file browser, it'll also automatically do that, which is why I was already connected. So I'm just going to go ahead and hit connect. And then when it's done, it should have a little green button here or a little green check mark, and it'll tell you how much RAM you have and how much disk you have. So I'm on Colab Pro Plus on this, which means one of the nice things about Pro Plus is you also get a bigger disk size. If you're on the free version, I actually have a free version that I might show next week. I might try to work in free just to sort of see how it goes for all of us. But the free version will have slightly less disk space, slightly less RAM, like that sort of. It's basically they want to encourage you to upgrade. So just be aware of that. So it sort of covers this area. Most of the working area that we're going to work in is this area here. So you'll see that there are text cells and there are code cells, right? So a text cell is just a bunch of text. And if you double click on this text cell, you'll see if you're familiar using Markdown, this is all Markdown. So you can change the header style here to being in H1, H2. You can wrap stuff in code markup. You can do links. Again, if you want to take your own notes or want to make your own notebooks, we can talk a little bit more about this. But for the most part, for the first half of class, you're probably just going to use pre-made notebooks. So other than adding your own notes, you probably don't need to worry about it too much. So that's a text cell. The most important part of this class will be the code cells. So these are little cells of code. There's two ways to run a code cell. The first is to press the play button here. So you hit play. And it will basically run the cell. So this is, these all work in Python. You don't need to know Python for this class. I'll basically show you anything you need to know. But this is just a Python command that says print, and it prints out this to the console. So you press the play button. Pressing the play button gets annoying after a while. So the cool way to do this is to hit shift return. So if you don't see me press the play button and you see our cell running, it probably means I just hit shift return and didn't say that. So shift return is just the easy way. So if you remember just hit shift return, it'll always run. So I can run this multiple times. One thing to note is a cool little feature of this is there's a little number here that tells you what order your cells ran in. And so I've run this 3 times now, so it's 1, 2, 3. A really important thing to remember, and this gets really confusing and everyone screws this up, the order of operations in which you run commands matters. So if you're used to just using a text, like a code document, like something like P5, all the code is in one place, so it's just easy to remember sort of where it is. with cells, because they're sort of like cells strewn across the notebook, you might forget that you ran things in the wrong order, and that gets really confusing. So here's an example of what that looks like. So we're going to run this code cell, and this code cell is just going to assign two variables. So it's going to assign the number 12 to first number and the number 25 to a variable called second number. So when I run this, that's now saved into our runtime. So nothing got output because all I did was assign some variables. Now when I come down to this cell and I run this here, it's going to print out those variables to me. It's going to say 12 plus 25 equals 37, right? So I ran this here and then I ran this here. Now what I'm going to do next is I'm going to change the variable for second number to 30 instead of 25. So it's always also really important to know that even though you've like sort of written out the code for this variable, you have to run the cell to actually save it to your runtime. So we're going to run the cell. So now second number is no longer 25, it's now 30. So if I come up here to this cell and I run this one again, now it's 12 plus 30 equals 42. So even though these cells are in different orders, the order of operations changes what the runtime sees as the variables. This will get confusing, and I promise all of us will screw this up, including me. But just know that often, sometimes if things aren't working, it's like, okay, did I run this in the right order? So most notebooks we're going to find will tell you like run from the top of the notebook to the bottom. And if you run that, it'll just work. But then you'll want to go in and tweak things or like edit things. And then you want to make sure that you're running things in the right order. So this is kind of the hardest part about Colab, is just knowing you're running things in the right order. And sometimes these little numbers will just help you sort of remember, okay, I ran this at 4, now we're at 6, 7. So like, this is out of date, or like things might have changed here that are now no longer true. So it's just helpful to keep that in mind. So GPUs are sort of the backbone of what we need for this. The reason we need to use a GPU is machine learning processes are very small little numbers, and we need to move lots of them over time. And it turns out that a GPU is a better way of handling that than a CPU, right? CPUs run linearly, GPUs can run multiple processes all at once. So it turns out that, basically cool that we figured out that a gaming card was going to be better to use. So we use a lot of GPUs. By default, most notebooks will default to a GPU, but if you get an error that says like, hey, I don't see a GPU here, you might need to change that. So this is currently running in CPU mode. When I run this command, this is just a special command to spit out all of my GPU information. It's probably going to throw an error. So let's just see what happens. Yep. So it says, whatever failed, and you're being like, what the hell does that mean? That basically just means that we don't have a GPU set up. So it's very easy to switch between CPU and GPU mode in Colab. The problem is that you're going to lose all your work. So if you've uploaded a bunch of files and realized you were in CPU mode but need to be in GPU mode, you're going to have to do all the uploads again. So usually what I recommend doing before you even open a notebook or before you run it is go to runtime and then go to change runtime type and make sure hardware accelerator is set to GPU. By default, pretty much any notebook I share with you, except for this one, is going to by default be set to GPU. But it's probably good to just check anyway, just to be safe. So once you hit save, it's going to restart the notebook. So you'll see it reconnecting and initializing. And now when I run this cell, now it spits out a bunch of information. We don't need to really worry about anything here. The most important thing that we want to look at is this line here. And this will say Tesla P100, V100, A100. That's what type of GPU we have. And this line here will tell us how big of our GPU is. So this is a 16 gigabyte GPU. If you get, what are the other options here? So here are some of the options. There's a P100, there's a T4, and a K80. The T4 is 15 gigabytes of VRAM, and the K80 is 12 gigabytes of VRAM. When we start to work with stuff like StyleGAN at the highest resolution, we're kind of going to want to make sure we have a 16 gigabyte GPU, because otherwise you're going into memory errors. Also, some of the newer text to image models also need 16 gigabytes. So basically what they give you for free are usually the T4 or the K80, right? So that's why they kind of suck. Once you get to Colab Pro, you can usually get a P100 or a V100. And now there's an A100 that they just added recently. And that's pretty much only available for Pro Plus. So this will make more sense as we start to work through these models and actually see like speed is really slow. Why is that? Oh, it's because they have a K80, that sort of thing. So just be aware of that. There's more notes in here in the notebook that if you want to look at this week or next week, we can talk through more of that, but that's the important thing to know. Lastly, there is a really cool, because it's all Google, it's all integrated with Google Drive. I highly recommend that if a notebook doesn't have Google Drive integration, you just need this code cell. So you'll see this pretty much everywhere in all of my notebooks. Also next week, when we add the snippets files to our own collab setup, we can then quickly copy this over. The way to connect to your collab setup is you just run this cell. And it's going to say, are you sure you want to connect to Google Drive? And you'll say, yes, connect. I believe for anyone that's the first time they're running this, you're going to need to come here and like maybe input your password again or something. But for the most part, you just connect it and you'll hit allow. And when you're finished, if we refresh our browser over here, our file browser, quite often, for a reason, files don't often auto update in this file browser on the left-hand side here. So if you click this little refresh button, you'll see now I've got a folder in here called Drive. And if I look in here, you'll see I've also got a thing called My Drive. And inside of My Drive, literally all of my files in Google Drive. I have a shit ton of files in Google Drive because I use this all the time. The other note is that if you have multiple Google Drive account or multiple Google accounts, if you have an NYU account, maybe a personal account, you can only connect to the same account you're using your notebook from. So in this case, I'm using my personal Drive account or my personal Google account. If I were to switch to my NYU, I could also run a notebook from there. So what I'd probably recommend for you, I don't know what everyone's doing. NYU probably has pretty much like unlimited drive space. Yeah. So make sure that you're running all these from your NYU account. So you can just save a ton of files to your NYU account. It's way easier. The other thing I'll say is like, because of that, if you do have multiple Google accounts and you're going to sign up for Pro or Pro Plus, make sure you do it on your NYU account because the accounts are actually connected to whatever account you're using. So make sure that you're also paying for NYU because then you can use that drive. And like, we're going to create lots of very large files. So we'll make sure we're saving those to a place where we're not going to get dinged or asked to be paying Google more money. So I'll cover more of this when we actually start going through notebooks next week. But I just want to give everyone a sense of like what we're going to be doing. One of the challenges here is that I know like not everyone in here is super into code, and there will be lots of big code cell blocks, and you'll be like, do I have to understand what this means? In most cases, you don't. It's fine, just run it. When we run into errors, which can happen quite frequently, it'll be my job to sort of help guide you through those things. If you are into code, start to read through them. Most of these will be written in PyTorch or TensorFlow, which is pretty hard to read. I barely understand half of it myself, but we can try to work through them together if you're interested in learning more about that. Sound good? Cool. So next week, we'll pick up from here and we'll start to actually look at some collab notebooks and we'll walk through a couple. And then we'll do some demos together. And then we'll just sort of, I think next week I'll be like starting to get comfortable with collab. So your homework will basically just be like, start playing with a bunch of collab notebooks. At the very end of this notebook is actually a link to a bunch of our, ML art notebooks that I've sort of been collecting, as well as tutorials. So if you're really amped and ready to go and want to start to play with this stuff now, at the end here, you can start to click this link and you'll find a bunch of new notebooks you can start to play with. We'll cover more of this next week. So if you are also just like, I kind of have had enough this week, it's cool. We'll cover more of it next week. Sound good? All right, cool. We'll see you next week then.